Hello everyone, good day to Dr. Jamil and my friends. Today our group will present mini project. The title of our group mini project is Real-Time System on Arduino. Our group got four members. First is Tern, second is KIROSHA, MACHAP, and myself is JIVETHA MURUGAPOOPATHI, and SHAZWANI, BINTI, ZAINON. Okay, for the objective, is to build a basic real-time system on an Arduino Uno board. Second is to use the knowledge of preemptive predict scheduling in real-time system from previous lab. Third is to demonstrate effective project management skills in solving given problems. Second, I will present about the equipment and tools. In this project, we have used PC workstation. Second is Arduino IDE with real-time extension. Third is Arduino Uno board. Fourth is 10 kilo ohm potential meter. And fifth is 10K resistor. And sixth is LDR sensor and LED green and LED yellow. That's all from me. Thank you so much.
Hi, speaking to Dr. I'm going to explain about the introduction to the project. A real-time system is a computer system that provides timely response based on specific time constraint or the risk of the system failure. In real-time computing, the accuracy of result depends not only on their logical correctness but also on the time at which they are produced. So deadline refers to a specified time by which the response must be completed after an event occurs. The mini project aims to illustrate the usage of an Arduino in conjunction with the real-time operating system. It demonstrates how the Arduino is effectively integrated with and modules, showcasing the communication between hardware and software components. The provided diagram outlines the initial step for developing a real-time application. It involves utilizing a variable resistor and on LED sensor to control the input voltage that enters the Arduino through the analog input. Based on the voltage level, specific actions are triggered. When the voltage entering the system falls between 2.5 voltage and 3.3 voltage, the green LED is illuminated. If the voltage exceeds 3.3 voltage, the yellow LED lights up. In all other cases, meaning when the voltage is below 2.5, all LEDs remain off. This setup allows the responsive system that reacts to different voltage level by indicating the corresponding LED states. The executive summary for this project is: in real-time system, the scheduler is a crucial component, particularly a short-term task scheduler. This project focuses on developing a periodic scheduling system under real-time conditions. The report encompasses essential information such as an introduction, objective, equipment, and tools used, discussion, result, and output, and conclusion. In this project, an Arduino board is employed to implement a real-time operating system instead of using Arduino real-time extension, which is no longer available due to advancement in technology. The chosen operation system allows for multitasking and scheduling, enabling execution and execution of multiple loops at different rates or time intervals. However, the structure of the two applications differs, employs a programming model with void loop in the point of declare inside function. The parameter varying system by controlling LED, turning them on or off. The project consists of 5 voltage measurement from the variable resistor, voltage measurement from the LDR sensor, and the process of serial monitor, controlling the LED green and controlling the LED level.
Good day, sir. My name is Tern. So now I would like to present the source code that we'll be using in our Arduino Uno board. So here there will be the execution time for our task. Task 1 will be assigned with 1000 milliseconds, which is 1 second, and task 2, which is 1.5 second. And our task period will be assigned with here. Task 1 will assign with 7 seconds, while task 2 will be assigned with 5 seconds. Since we have enabling the ARTE Arduino real-time extension in the Arduino board, so the task will be scheduled with the according to the rate monotonic scheduling, which is the highest period will have the lower priority, while the lowest period will be having the highest priority. So we can see here just now the loop 2 will be the task 1 execution, because here we can see the period we assign with 7 seconds, so it will be execute later, while loop 1 will be execute first. So the loop 1 is actually controlled by the potentiometer. So every 5 seconds, the LED will be light up, which according to the condition, if greater than equal to 2.5 watt and less than and equal to 3.3, so the LED green will be turned on. If it's greater than 3.3, then the LED yellow will be turned on, while the task 1 will be scheduled later, which is also according to the task. But here we were using the LDR sensor, which sends the light to get the voltage, and the condition is the same with the potentiometer. So here we have drawn a timing diagram for task 1, which is a control by the LDR sensor, which having the execution time of 1 ampere and 7, and the potentiometer using 1.5 second for execution time and 5 for period. As you can see this timing diagram, since we are using the rate monotonic scheduling, so for task 2 it will be executed first, then followed by task 1. But at time 20, you can see task 2 will be still scheduled first, then followed by task 1, although we meet the new period for task 1. Because task 1 have the lower priority than task 2, so task 2 will be continue to execute first, and it will going until the period of 35. So now I would like to show you the demo video of our project.
Hi, Assalamualaikum warahmatullah. My name is SHAZWANI binti ZAINON. So this is our simulation for mini project in practice. As you can see, we use an Arduino Uno as microcontroller board. 4 LED, which is 2 LED yellow and 2 LED green. 5 resistor, 1 touch LDR, 1 potentiometer and 1 DC voltmeter. So how the simulation works is if the value above 2.5 and below 3.3, the LED yellow will off and LED green will on. So the value here is 3.00. So the output will be green on. And next, if the value above 3.3, LED yellow will on and LED green will off. So here the value is 3.50. So LED yellow will on. That's all.
So from here you can see when the LED that controlled by the potentiometer, the voltage which is greater than 2.5 and less than 3.3, the green LED will be light up. So when going to the second condition, which is the voltage greater than 3.3, the red LED will be light up. But using the LDR sensor, since in the laboratory that the hardware having some technical problem, and we have shown the operation while in the lab to Sir, so we know that the LDR sensor there will be some problem that it cannot sense too much lightning, so the voltage reading can increase to the certain value which is greater than 2.5 or 3.3.
So this is a conclusion for our mini project. We will be able to build a real-time system on an Arduino and comprehend its operation at the conclusion of this mini project. Additionally, we can carry out 5 activities, one which is learning how to measure a voltage from a variable resistor. Furthermore, we know now how to detect voltage using the LDR sensor. Also, we know now how to show the procedure for LED green control and LED yellow control on the serial monitor. Not to mention, every operation is managed in real time. The system has quick response times and is effective and efficient. Next, this is our recommendation for our mini project. Use potentiometer for variable resistor since it was one of the simplest and least expensive way to deal with dim LED drivers. It can be applied here to regulate the LED's brightness. Second, employ simulation since they can produce precise results. We made the simulation with using Projject 8 proportional. That's all for me, SHAZWANI binti ZAINON.